chloride plus what? Water. Abi? So it is 1:1. Abi? 1 mole to 1 mole. So it is 1:1. So of course you know the formula that Ca what? Over what? V what? Equals to Na over what? Mb. So CaVa, concentration of acid, volume of acid, concentration of base, volume of base, molar ratio of the acid, molar ratio of the what? Base. Since it is 1:1, I can cancel both. But don't cancel so I don't make mistake. So you know what to do. We are looking for Va. So yes. So we are looking for Ca. So this will go here, this will come here. Okay, we'll now have, since they are 1:1, I can just cancel them. This one will go there. Now I have CaVa equals to what? CbVb. Since I'm looking for Ca becomes CbVb over Va. So what was Cb? Concentration of the base. Eh? Talk now. Zero. Concentration of the base is what? 0.1. Yes. Volume of the base was what? 25. Volume of the acid is what? Eh? Eh? Volume of the volume of the acid is 25. Volume of the base is 30. Volume of base is 30. Please, not go miss the value. Then 25. So punch your calculator. 0.3 times 30 over 25. What do you have? 0.12, right? Okay. So 0.12 molar concentration. So that's the volume of the what? Acid. No, and the rest, most of them here are theory, so we'll just brush through. So number 15, no time. Number 15. How many of you understand the ones we have done up to this point? Okay. Alright. If you dey follow, you suppose they get the gist. You get. Just as some of us, naturally, we have phobia for chemistry. And some of us are still suffering from the PTSD trauma of Chem107. The thing was very funny. 100 questions. It's not easy. It's not easy. So let's do 15. Number 15. What is the hydrogen ion concentration of a solution whose pH is 5.3? Now there are two ways to solve this. Manually, you can just test all the concentration. You know what to do, Abi? Just say minus log, open a bracket, put 5 times 10 to the power minus 6. Find the one that will give you, test all the options, find the one that will give you 5.3. That is the answer, Abi? That is when you have calculator. So you can use that and you will get option A. But let's say in a scenario whereby someone stole your calculator while you were entering the exam, or as you just enter the calculator for your back pocket. Okay, let me solve it manually. When you want to solve for concentration, there's a trick we usually follow. You know, normally it is always n times 10 to the power minus x. If you see all the concentrations that they will always give you as regarding pH is always negative. I follow you. You will not say 10 to the power 5. It's always minus. It has to be negative. So the n here is the number, the x is the power. Negative. So when you have a pH, if the pH given in this scenario is 5.3, x is always the next number in terms of rounding off. Are you following? X is always the next number in terms of rounding off. So in terms of rounding off now, what will be x in this place? 6, right? Okay. So if the pH is 5.3, my x will be what? 6. So x will be equals to 6. So let's say, for example, they give me a pH of 4.1, 4.2, 3.2, 3.5, 2.1. X will be what here? X will be what here? X will be what here? X will be here, what here? What about here? So it's always the next number when you round off. You get? So it means my x will be 6. So normally, if maybe these guys are not wicked, I'll just go through the questions. I'll just look for the one that have -6 and I'll just pick my answer. But if you do that, you see that two options has -6, right? E and A. So you can't pick using that strategy. So you have to now find what N is. So to get N is always X minus the pH. N is always what? X minus the pH. So it's going to be what? 6 minus 5.3. 6 minus 5.3 is what? 0. What? 7, right? Good, 0.7. So when you get to this place, you now ask yourself, which log will you punch your calculator that will give you a value of 0.7? Don't stress yourself too much. Since you already know that the answer is between A and E, so you now check, is it log 5 or log 6? So log 6 is what? Log 5 is what? What is log 5? Sorry, what is log 5? Yeah, what is log 5?
0.69.
That is 0.7. What is log 6? So normally you need to know log 0 to log 0.77. That is 0.8. So you see that log 5 is equals to 0.7, right? So it shows that my n is going to be 5. Are you following now? So my n is going to be 5. So in this case, my n is going to be 5 times. So I'll now put 5 here. So if I put 5 here, I'll now have 5 times 10 to the power minus x is what? 6. So if I do minus log this now, I will have this. Sure you get this stuff? So in exam time, if they bring something like this and you know you cannot go through this, just test all the options. Minus log. Let's be down. Please let's be careful with the sound we make. Yeah. That was how I was teaching in one GBA branch tutorial and they made funny sound. They thought their face was high. You know when you have adrenaline, can actually when they jump this place, they come down and you no go know. You won't feel the pain. So let's be careful, please, with the sound. So when you have this kind of question, test all the options. Are you following? You have calculator, so test all the options. Anyone that gives you 5.3, that is it. But if you don't want to use that method, you want to solve manually like this, you can also do this. So that is that. So the second question said 16. So what is the pH of a solution if you mix equal amount of hydrochloric acid and ammonia? Now, hydrochloric acid, is it a weak or a strong acid? A strong acid. Ammonia, is it a weak base or a strong base? Is a weak. Ammonia is a weak base. You get. So when you mix a strong acid with a weak base, the solution is going to be acidic. The only way the solution will be neutral is if you mix a strong and a strong base. A strong acid, a strong base. If you mix a weak acid with a strong base, the solution will be basic. If you mix a strong acid with a weak base, the solution will be what? Acidic. So, but it will not just be too acidic, it will be slightly what? Acidic. So these guys are smart. That was why if you check the option, they just put only one that is acidic. They didn't put something like 6, 5, 4, 3. No. Because they know that you cannot just gauge the exact pH. So they now put one that is a little bit slightly acidic. So which is option what? A. You know, from if you look at your pH, middle is 7, 14, and what? 0. You know, from here downward is acidic, abi? As you move from here towards this region, the acidity will what? Increase. Meaning for you to be more acidic, you have to have a low pH. So when you have a high pH, you will be less acidic and you'll be more alkaline or more basic. You get the gist? So from here downward, more acidic. From here upward, more what? Basic. You get? And acidic or acidity is inversely proportional to what? Basicity. Meaning the more acidic you are, the less alkaline or basic you become. Sure you get? Okay. So the answer to that is 6 because 7 is neutral, 8, 9 are alkaline. 6 is slightly what? Acidic. Okay. The next question says, which indicator is most appropriate for the determination of the molarity of H2SO4 using standard sodium hydroxide? So before I tell you why you should pick A, if you see it on Monday, you see it tomorrow, is I'll have to explain indicators for you and the types and where you should use them. So what are indicators? If you are writing, they are they are weak organic acids or base. Indicators are weak organic acids or base. Indicators are weak organic acids or base, which changes color in the solution depending on the hydrogen concentration. Indicators are weak organic acids or base, which changes color in a solution depending on the hydrogen concentration. So we have different types of indicators, like are different. We have, we'll just talk about the ones that are common in the chemistry department. We have litmus, litmus paper. We have methyl orange. We have phenolphthalein. We have bromophenol. So these ones are the ones common in chemistry department. Litmus paper, methyl orange, phenolphthalein, bromophenol blue. So these are indicators. Remember I said they are what? Weak organic acids or base. Weak organic acids or what? Base. You get, and they change color whenever you put them in a solution depending on the hydrogen concentration. So if we want to check these guys, we have in acidic medium and we also have in basic medium. We have acidic medium, we have basic medium. So in acidic medium, litmus paper change color to which color? Eh? Blue. Red, right? Okay. So red. Why in basic it is what? blue. Abi? So if maybe no worry, in second semester you will do the titration that involves litmus paper. Yes. You see litmus paper, you see filter paper for the first time. Some of you have not seen it. I understand. You see it. They don't eat it, so they don't lick it. Some of you will say, ah, let me lick it. Don't lick it, please. So in acidic medium it is red, basic medium it is what? Blue. Metal range in acidic medium is also red. Are you following? It's also red. But in basic medium it is what? Yellow. Phenolphthalein in acidic medium it is colorless. Colorless. Colorless also means white. Abi? Eh? In case maybe you don't see colorless, you pick white. Why in basic medium it is what? Pink. Bromophenol blue in acidic medium it is yellow, but in basic medium it is blue. So these are the indicators, these are the color changes you should know. Now, in titration, they have different indicators you use depending on the titration you are carrying out. We have titration whereby you titrate a strong acid with a strong base, strong acid with a weak base, a weak acid with a strong base, a weak acid with a weak base. So we have different. So we have strong acid plus strong base. We have strong acid plus weak base. We have weak acid plus weak, sorry, plus strong base. And we have weak acid plus weak base. So this is under titration. Okay. So these are the indicators you use. Back then, nothing invest me pass. I come back from church. Think it say they don't cook. Now when I reach house, they come say they grind tomatoes. It shall be come and go and eat mama will be and grind tomatoes. And you know, say all those tomatoes they grind with machine, they'll come for parboil for like 1 hour. So Sunday like this will just put your mind now around that kind 5:30 to 6 you chop. Mostly if your church now Christ Embassy, when it close around 2. So you can't afford to you can't afford to quarrel with your friend when it is getting to Sunday because your friend side you first go collect 1 or 2 dine first chop before you come. You can't afford to quarrel with him. Even if na quarrel on Saturday night, go beg am. So that Sunday go give you rest because maybe that mama mostly that mama no dey go church. So they will get time to cook first before now come back. Those were trauma. Okay. I hope all is well. All right. Strong acid, strong base. Now, when you titrate strong acid and a strong base, you can use any indicator. You can use what? Okay, there was one I didn't put here. It's called universal indicator. This one, you cannot put a color this thing. The reason is because it changes. I mean, of you have seen this animal called chameleon. Have you seen chameleon? Change the way it changes color in different environments. That's how this guy change. If the pH is 5, you change color. If it's 6, you change color. If it's 7, you change color. You get. So you cannot pinpoint one particular color for it. So the reason why they call it universal is because you can use it in any titration, whether strong, you can use it. You get, it goes with all of them. So if you are using strong acid, strong base reaction, you can use any indicator. Any what? Indicator. But most preferably, you can use phenolphthalein. So you can use any indicator, but it is better if you are working in Uniben lab. Let me use Uniben lab. Go with phenolphthalein. Now that one they get for that, not many pass for there. Now why they always use that? Not many pass. Then strong acid, weak base, weak acid, weak. Now, yeah, this one might confuse you. Are you following? It's my but you can use this to remember. SAM, WAP. Are you there? You can use it to remember. So strong acid, you use what? Methyl. Then weak acid, you use what? Phenolphthalein. Of course, there's sometimes I usually tell people, which is true. If you know, say, this one on your right hand, automatically you will know, say, this one on your left hand, abi? Abi, or second say, na your left hand be this one. Since you know, this one on your right, suppose this one on your left, abi? So if you know that, okay, this is strong acid, suppose no say wetin dey react am with na wetin na weak base. And since you know say this one na weak acid, suppose no say wetin dey react am with na wetin na strong base. So when you have strong acid, it automatically means the next one will be weak base. So you are going to use what? Methyl orange. So use methyl orange. But when you use weak acid, it's going to be with a strong base. So you use phenolphthalein. Then a weak acid plus a weak base, there is no suitable what? Indicator. No suitable indicator. So it's good to know you know this stuff, you know this, and you know this. It's very good. They must ask you something from this place. They must. So it's good you know it. Don't cram, just know it. Okay. So number 17, now you know why phenolphthalein is correct, right? So yeah, let's move ahead. Number 18, he said, in which reaction would phenolphthalein be a suitable indicator? It has to be what? It has to be a weak acid and a what? So if you look at number 18, you see that option B is the one having that combination. Ethanoic acid is a weak acid. Sodium hydroxide is a strong what? Base. So that is it. Okay. Number 19 said, which of the following is the strongest roasted acid? So what are roasted acids and what are roasted bases? This is Chem101, right? This is Chem101. Roasted acid are substance that donate protons. Are you following? Roasted acid are substances that donate what? Proton. Roasted bases are substances that accept what? Protons. So in number 19, option A is the right answer, which is ozonium or hydrozonium ion, H3O plus, is a strong roasted acid. Now, sodium hydroxide is a base. Sodium, hydrogen sulfate, I think that is like a salt. Ammonia is a base. Hydrogen fluoride is more like an acid, but hydrogen fluoride, the combination is very strong. The hydrogen bond in hydrogen fluoride is very strong. So fluorine will not let go of that hydrogen. So the answer here is H3O plus because the bond in H3O plus is dative or coordinate what? Bond. So which of the following is the strongest Bronsted base? So this answer is O2 minus. In case you see it, it is O2 minus. Um, O2 minus have more chances of accepting more electrons, more protons, sorry. When I first saw the question, I actually thought it was OH minus, but I made my research and they said O2 minus have more ability to accept proton than OH minus. I think the reason is maybe because of their ions. OH minus is one ion, O2 minus is two. So it's more like it's accepting two. You know, when you accept, you become negative, right? When you give out, you become positive. So OH minus is accepting one, O2 minus is accepting two. So which one is greater? O2. Number 21. We are making progress. Which of the following is the weakest Bronsted acid? Of course, you have to go for the one that is a base, right? You know, anything that have OH is a base. Now, I know your past question told you that aluminum tetraoxide here is amphoteric. Forget that language. It has OH, so it's a base. And like I said, if you are more acidic, you become less basic. If you are more basic, you become less what? Acidic. So because this guy is a base, it is less what? Acidic. So that is why aluminum trioxide is what? The answer here. Now the other 22 said, which of the following is the strongest and among the series of acids formed by chlorine? Now this is chlorozoacid. Are you following now? Chlorozo acid, like chlorine oxygen acid. So chlorozo acid. Now, in terms of chlorozo acid, the more the oxygen, the more the what? Acidity. Are you following? Please now. The more the what? Please, if you know you connected, please disconnect, please. Please, don't disorganize. Today is Sunday, please. I'm using my last ATP. That's why I'm not shouting. You get? So please. The more the oxygen, the more the acidity in ozochloro acid. Chlorozo acid, sorry. The more the oxygen, the more the what? Acidity. So if you say this thing was increasing, so if you have to write this in terms of increasing order, it is HClO less than HClO2 less than HClO3 less than HClO4. So this is more acidic before this because of the oxygen you get. So this is called perchloric perchloric what? Acid. Perchloric acid. So the more the oxygen, the more the what? Acidity. Please don't go and click and that sorry, don't go and shade another thing. 23. Which of the following compound is the most acidic? Which of the following compound is the most acidic? Now, if you look at this question, look at it very well. You see that they have the same concentration, right? 0.1, 0.1, 0.1. So all of that, so you cannot use, because normally you can use concentration to determine the acidity. The more concentrated, the more acidic. But in this scenario, you cannot use their concentration because the concentration is constant. So two things you can use in this place. You can use the numbers of hydrogen ions they have, or you can use their pH. You get? Like I said, this is a generated question. So therefore, that was why they put pH. Because if it's not a generated question, they will not put pH. They'll just put H3PO4. Finish. So if maybe there was no pH, I'll use the hydrogen concentration. The one that have the highest hydrogen concentration, we have the highest what? Will be what? More acidic. Because at the end of the day, I'm going to times that concentration by 3. For like option A now, the concentration will be 0.10 times 3. Option B, the concentration will be 0.10 times 2. You get. But since it's a generated question and they place pH there, You use pH to determine your answer. So the less the pH, the more the what? Acidic. So option A has the lesser pH. Therefore, it is the most what? Acidic. But if there was no pH, let's say they now re-edit the question and they didn't add pH, what will you use? Hydrogen concentration, Abi. Look for the one that has the highest numbers of hydrogen, which is H3PO4. So that is it. So 24. In which of the following is phenolphthalein suitable with? Of course, I think we have answered that question already. They repeated it. So we have answered it already. When is an acidic oxide formed? Acidic oxide is formed when a non-metal reacts with what? Oxygen, right? So when a non-metal reacts with oxygen, they form acidic oxide known as acid anhydrides. So if acid anhydrides dissolve in water, they will produce an acidic oxide. But when a mental reacts with oxygen, it forms basic what? Oxide. You get? So if you look at that option now, three options are mentals. One option is what? Non-mental. Calcium is a mental, rubidium is a mental, sodium is a mental, selenium is a non-mental. So option C is the right answer. In which of the following solution is the strongest oxidizing agent? Permanganate in acidic is the most oxidizing agent. Permanganate in acidic medium is the most oxidizing agent. Now, another one that follows it is chromate in acidic. What is that? Chromate in acidic. You get is also strong, but it is not compared to permanganate. KMNO4 is a very strong oxidizing agent. You get? So if you see that question, just look for permanganate in acidic what? Medium. Don't worry, it's going to be Lucan. No, let me know is that word.